around. Translate, shift it left, right, up or down. Reflect, copy it across analysis of symmetry. Rotate, turn it round. Translate, shift it left, right, up or down. Reflect, copy it across analysis of symmetry. Hey.
Well, welcome back, geometry students. As we get into 4.2, our big ideas, we're looking at transformations in this chapter. We already talked about translations, and that song by Colin Dodds. He's a guy who does a lot of math songs, really cool ones on YouTube. He was just showing us that you can do really 3 of them so far on that video, was rotate, reflect, and translate. We've already looked at the translations. We're looking at reflections in this lesson, and rotations are coming up with the next one. So we're going to be performing these reflections and performing glide reflections, looking at lines of symmetry. Before we get into all of that, let's do our little cartoon here. So this looks like at the aquarium perhaps, and the shark exhibit. The shark is saying, "So close yet so far," as he looks at the little boy behind the other glass. All right, so as we get into our core concept, page 99 looks at the reflections, and you want to just highlight here, because these are vocabulary words. Reflection, it is a transformation that uses a line like a mirror to reflect a figure. So just like you're looking in the mirror, you're going to see your reflection looking right back at you. So the mirror line is called the line of reflection. And so we look at the points here. We have a point P and a point P prime, so the blue one and the red one. And we're going to reflect it over line M here. And so you're going to see how that's going to reflect. It's going to look exactly the same distance away from line M, just like if you're at the mirror, and as you get closer with your hand on the mirror, they come together eventually as you're touching the mirror. It's like you're touching your hands together. So it's the same idea here. You're going to be exactly always congruent. These are always going to be the same distance away here. That's why the congruent marks are there, and you see a right angle as well. And you can see if it's on the line, the reflection is just the same exact point if it's on the line. So that's what you see on a couple of things here. So reflection in a line M maps every point P in the plane to P prime, so that each point of one of the following properties is true, and that's basically what we were just talking about. They're congruent, they're the same distance away, and they're perpendicular. And if it's on the line, then P is equal to P prime. They're exactly the same point if your reflection is on the line of reflection. Now the next core concept on the top of page 100, this is the one that you're going to need to go back to over and over again. So you definitely highlight this one where it's coordinate rules for reflections. This is one you definitely want to highlight, because this is what we have to do to our points. As we find out what points they are, this is what we have to do to those points to be able to reflect them over some kind of line of symmetry or line of reflection. Now the line of reflection sometimes is the x-axis and the y-axis. So you can see the first two, that's the line of reflection here. Other times the line of reflection is an equation. Like this one is y equals x, this one is y equals negative x. So it's a line, it's actually an equation. Sometimes it could say, y equals a number, and then that would be a horizontal line going through, or it could be x equals a number, and that would be a vertical line going through as well. So it could have those also, and we'll see some of those on the extra practice. But for the first bullet here, it says when you're going to reflect a point, and A, B would just be like your x and your y. So when you're going to reflect a point in the x-axis, what's going to happen here is that it's going to really just change the sign of the y-coordinate. So basically, if you can think about it, if it's reflecting in the x-axis, then the x-coordinate stays the same. It's the y-coordinate that will turn to its opposite. So x stays the same. If you're reflecting in the x-axis, then x will remain the same. It's the y that changes to its opposite. And then for the y-axis, if you're going to reflect a point in the y-axis, then the y will stay the same. It's the x-coordinate there that's going to change to its opposite. So it's just going to be changing a coordinate to its opposite. That's going to reflect it. Now, if it's reflecting in this line, it's y equals x, what is that line? That's this line here, as you can see that. And you want to draw this there underneath, maybe this core concept or on your paper. Just a little quick coordinate plane, and it's going to just be a diagonal line going through. Slope is 1, so it goes through the origin right here, and up 1, right 1, up 1, right 1 each time. That's the y equals x line. And so if we're going to reflect it in the y equals x line, then what's going to happen to our a and our b this time, or our x and the y coordinate, is they're going to switch places. So if it's the y equals x, they switch places. They don't change to their opposites. Nothing changes to their opposites here. They just switch places. But then if we're going to reflect it in a line that's y equals negative x, then all the points, all the coordinates of whatever we're reflecting there, so it's going to be, and this line here would look like this. It's just the opposite direction. It's the negative slope. So it's up 1, left 1, up 1, left 1, still going through the origin. Go ahead and sketch this one as well so you can know what that line looks like. If you are going to reflect in that line, then what happens here is, since it is a negative x, both of your coordinates will turn to their opposites. So both change to their opposites. X and y both change to the opposite sign. So not necessarily just negative, but this means their opposite sign. So when you're seeing negative b, negative a, that means that you're going to change their opposite sign. So if these are originally negative, then they'll change to positive. What also is going to change is they're going to switch places as well. So they do, just like this one, switch places, but they're changing to their opposites also. So that's what's happening to every coordinate if we're reflecting it in these particular lines. So we got to keep going back to this and referring to this to see what we're going to do. Okay, so still on page 100, right there at the bottom, we have 1 through 4. It says that we're going to graph a triangle ABC and its image after a reflection in the given line. Now remember the terminology here. Image is the new figure. So the original here with these coordinates, this would be called the pre-image, and then the new one that we're going to graph after the reflection in the specific line of reflection they give us here, that's going to be called the image. So let's just first on this one, number 1 here, graph these points. Just plot the points. Now on this coordinate plane, to be able to fit all these points in, because we only got it like going 4 boxes each way, we're going to need to make every box worth 2. So realize that. We need to make each box worth 2. So it's going to be 2, 4, 6, 8 each way. So this will go up to 8 each direction. And so for letter A, we're going to start off with -1 and 5. So -1, 5 puts us kind of up here. So half box 1. There's 2, there's 4, 5 is going to be kind of right up in here. So let's go ahead and plot that point there, A. B, -4 to the left, that's going to be 2 boxes this way, and then +4, so it'll be 2 boxes up. So let's put that point there for B. And then -3, 1, so -3 is going to be halfway on this box here, and then +1 goes up just a half, and we'll put it there. So we have our 3 points. We want to make a triangle, though. It says make graph triangle ABC, so we want to connect the dots, make a triangle. So let's connect all these dots together to make our triangle. And then we're going to reflect all of those points over the line of reflection that's going to be the y-axis. It's right here. Now we have to go back to that core concept that's right above this and see, okay, when it says in the y-axis, what do we do? Well, remember with all these coordinates here, your x and your y coordinates, they used A and B. But for all of these coordinates here, since we're doing it in the y-axis, the y is going to stay the same. It's the x that's going to change to its opposite. So that's why it says -A and then B. So this first one is going to change to its opposite, but this one will stay exactly the same. So let's go ahead and convert all of these points here to this using that little kind of formula. And we're going to call it A prime, B prime, and C prime, because these are your originals here. When you do an image, you're always going to use that little prime mark. So for A prime, it's going to be 1 and 5. It's going to be the opposite for the x coordinate, so +1. This will be the same for the y. B opposite here, so it'll be 4, 4. So B prime is 4, 4. And then C prime is going to be +3, +1. So this one turns to its opposite. -3 becomes +3 for C prime. And so now that we have those, we just go ahead and plot them on our coordinate plane. So for A prime, it's 1, 5, 1 this way and up 5. It'll be right over there. B prime at 4, 4, 2 this way, 2 up. And then 3 to the right and 3 and 1 up for C prime, and then you go ahead and do the same thing by connecting the dots together, and that should look like now a reflection just right over this. Every one of these points is exactly the same distance away from that line of reflection, like from the mirror. It's exactly the same distance. Number 2, let's go ahead and plot the points here for A, B, C. And on this one, we're going to have to do the same thing, and because we see this one's going to be 5 right here. We got some 5s in there. That's going to be too far if we go by 1s. So we got to go by 2s again in order to fit all these points in here. So 0, 2. So 0, 2 is just going to go up to right on the y-axis on that one for A. 4, 5. So 4 to the right, 5 up. So it's halfway there on that one. So B. And then 5, it's going to be 2 and then halfway. And then 2 up, just one box up from there. So here's another triangle here. Let's go ahead and draw the triangle, connect the dots. Now this one wants us to do the reflection in the x-axis. So if we're reflecting in the x-axis, that means the x-coordinate will stay the same sign. The y-coordinate's the one that's going to change to its opposite. So all of these, the 2, the 5, this 2, they will all change to their opposites. So let's write down this as well. So A stays the same, but B is going to be its opposite. First one stays the same, second one changes to its opposite. So on A, we're going to call it A prime. So it's going to be 0 and -2 for this one. And for B prime, 4 stays the same, 5 changes to its opposite. So 4, -5 for B prime. C, for C prime, it's going to be 5 is the same, but that'll be changing to a -2 for the y coordinate. And then we'll just plot these points for our reflection going down below here. So 0, -2, down 2, and then 4, 2 to the right, and 2.5 down for B prime, and C prime 5, 2.5 to the right, and then 2 down, or 1 down, I should say, 1 box down, puts us there. And so now we connect these together and make that triangle, and we can see again, just double check that every single one of these, your line of reflection is the x-axis. Every point, the A and the A prime are the same distance away, B and B prime are, and C and C prime are the same distance away. Alright, so number 3, starting the same way, but we're going to be doing it a little bit differently because it's not an x-axis or a y-axis this time. It's going to say y equals 1. This one says x equals -3. We're not even going to refer to the core concept up on top because there isn't anything you can refer to for, y or x equaling just a number. These are horizontal vertical lines. So we'll just kind of have to draw the line and then use that manually to kind of reflect it over that line. So first though, we want to just plot these points A, B, and C. And for this one we're not going to make the boxes 2 because there's nothing here more than 4. So we can use all the boxes just being 1. So let's go ahead and do that. So each box will be worth 1 on this one. So A is going to be 2, -1. So 2, -1 will be right down in here. And then B, -4. So 4 to the left, and then 2 down. B is going to be over here on the side in that third quadrant. And then -1 and -3 down here for C. All right, so down a little lower than that. There it is. That point right there, -1, 1 to the left, down 3 units, and down there for C. And then go ahead and connect your dots. So we'll connect the dots together to make our triangle. That's going to be our pre-image. We call it the pre-image. That's the original. And now we want to create the image by doing a reflection in this line. Y equals 1. So we got to look, okay, where is y equal 1? That's right here, and it's going to be a horizontal line going straight across. The y equals are always going to do that because it's got to go through 1 on the y-axis. And since there is no x in this equation, it can't touch x. It has to be parallel to x. So I'm going to draw that line in yellow here. You can do a light line as well if you want to with your pencil, or a dashed line there to show that's the line of reflection. So now what we're going to need to do is just manually reflect each of these points away. Now we know it's got to be right angles. Obviously it's got to be straight up. We can't go like this direction. That's not a right angle to this line of reflection. It's got to be perpendicular to the line of reflection here. So we're going to have to go straight up with all of these. And this A is 2 away from the line of reflection, so 2 above the line of reflection is going to be our A prime. Let's go ahead and put that right there at this point. That's going to be the coordinate 2, 3. That's going to be our A prime right there. And then for B prime, we got to go straight up, and it's going to be up 1, 2, 3, so it's 3 away from the line of reflection. So we're going to go 3 above the line of reflection, and that's going to be right here in this corner. That's going to be our B prime. It's going to put that one there. And then for C prime, this C is 1, 2, 3, 4 below. 4 below the line of reflection, so we got to go 4 above. That's going to be putting us a little bit above our coordinate, our little window here. It's okay. We can just go ahead and put that above there. Just kind of think about it. It's about 1 unit up. And let's go ahead and draw this triangle as well, connect the dots, and we're done. So that's all now completely reflected over this line. We had to notice that's the line of reflection with y equals 1, and we just have to manually kind of map each point using the fact that it's got to be exactly the same distance away from the line of reflection. Okay, so number 4 is going to be the same kind of way. Let's start just by just putting these points down. And this one, you can see, well, let's see, I got 2, 3. Now with this line of reflection being -3, I think I did do 2. Every box being worth 2, and we're going to see why in a minute as I put these down. Because we got to reflect it over a line that is x equals -3, which is going to be over here, and it's going to be so close to this side, most of my points are going to be on this side of the line, and we don't want that to happen. So we're going to go every box being worth 2 on this one as well. So -2, 3. -2 is 1 box this way, and then 3 is going to be a box and a half up. So right there for A. And then -2, -2. So it's going to be 1 box to the left, 1 box down for -2, -2. 0, -2 is on the y-axis here. It's just going to go down 2 units and be put right there. And so let's go ahead and draw this little triangle here with our connecting our dots together. And now our line of reflection is going to be x equals -3. So now we have to figure out where is x equal -3. So if we think about every box is worth 2 on this one. So this is going to be 1, 2, 3 is going to be right here in between this box. And it's going to be a vertical line because it's got to go through where x equals -3. And since there is no y in this equation, it's going to have to be parallel to y so it never touches y. So let's go ahead and draw that. You can do the same thing on yours. Sketch that line right through there. And then manually, we're just going to reflect each of these points over this line. So A right here is 1 to the right of the line. So A prime is going to be 1 to the left of this line, just right here, which is going to be the point -4, -3. That's what's going to happen there on that one, A prime. And then B is also just 1 this way, so it's 1 that way as well, right here at -4, -2. That's going to be our B prime. And then for C, C is 1, 2, 3 units away, 3 units to the right, so 3 units to the left. It's going to put us right over here for C prime. And so we'll plop C prime right there, and then just connect your dots together. And it should look like it's a perfect reflection over that line. It flipped over the line. That's what it basically did. All right, so page 101 at the top, we got 2 more here. Same idea. What we're going to do, we're going to see the actual pre-image on our graph paper here, on the little graph, and we're going to then reflect that over the line of reflection that it gives us here. And here's the ones where we're going to refer to that core concept back on 100 when it says the lines of y equals x and the lines y equals -x. So the first one, 5, y equals x. Let's go ahead and sketch that line. That's the line that's going to go through the origin, up 1, right 1, up 1, right 1 every time. So that's this line. Go ahead and sketch that on there so you can see you've got to reflect it. It's got to flip over this line. And what do we do with each of the coordinates here for A, B, C, and D? So we need to identify what these coordinates are. And what are we going to do with those? Well, remember, if you look at the core concept, it says that we need to flip or switch the A and the B. They just switch places. So our x and our y coordinates are going to switch places here. So for A, if we look at where A is at is at -3, so every box is worth 1 here, -3, +2. And so if we switch that, that's going to be 2, -3. So for A prime, that's what we want to write down, 2, -3. That's the kind of this point switching places. For B, it's 1, or I should say -1 and +2. So you switch places, +2 and then -1. And so we'll do that for B prime. For C, that is -1 and 1, 2, 3, 4. So -1, +4. So then go backwards, +4, -1. So we're just switching the places. So 4, -1 for C prime. And for D, that's going to be at -3 and +4. So +4, -3. +4, -3 for D prime. And now all we have to do is just plot those points. They should be over on this side of the line. It should look like a perfect reflection flipping over that line as we plot them. So let's plot A prime here. So 2 and then down 3 for A prime. So A prime is going to be right there. And then 2 to the right, 1 down for B prime. 4 to the right, 1 down for C prime. And 4 to the right, 3 down for D prime. And then we just got to connect the dots together to make our box, and that looks like the reflection over this line. We reflected all the points. They're exactly the same distance away from the line of reflection. All right, for number 6, this one's the y equals -x. Let's go ahead and put that line down. That's the one that starts with the origin as well, but it goes up 1, left 1. This time it just has negative slope, so it's going to be that line going that direction. And for this one, we're going to need to identify again all these points, A, B, C, and D of this figure. And on this one, if you look at your core concept, what does it say? It says to, yes, we are going to switch them like this, but we're also, since it's a -x, we're going to make it negative as well. So they do switch places, but they also change their opposites. Both of them do. And so let's look at where these are at. Now, A on this one, and every box is worth 2. Notice that. Each box is worth 2 because we got -8 here, -4, and so on. So you got to realize this A is at +2, 0. So +2, 0 for A. Let's write that down. It's going to be easier to actually write this down because we have to do 2 things to this. We have to switch places and make them both their opposites. Now 0 has no opposite. 0 will still be 0. So it's going to be 0 first, but then -2 second. So our A prime is 0, -2. And then for B, let's identify where B is at. So we got B at 2, 4. That would be at 5, going halfway here. So 5 and then 2, and that would be halfway for 3. So that's going to be at 5, 3 for B. Let's go ahead and write that down. Our B is the ordered pair 5, 3. So we have to switch places and make them negative. So 3 is going to go first, but it's going to be -3. 5 is going to go second, but it's -5. So -3, -5. And then for C, identifying C is at 2, and then we're going to go up 2, 4, 5. So 2, 5 is our letter C, our vertex at C. So switch places, so 5 is going to go first, but it's going to be -5, 2 is going to go second, but -2. And then for letter D, D is just going to go just a half a box here, which is 1 unit. So 1 unit here, and then 2, 4. So it's 1, 4 for D. And then if we switch places and make them both negative, -4 will be first, +1 will be second. And now all we have to do is plot these points, these 4 points here, for A prime to D prime. We should have the same figure just flipped over this line of reflection here. So 0, -2, so it's going to be 0, and then just -2 should be putting us right there for A prime. Oops, sorry, went the wrong direction. That was -2, 0. Should go down. 0, -2 would go down 2. I had it in the right spot. I just said the wrong thing. -3, so it's going to be -3 first this way, then down -5. That'll be down here for B prime. -5 this way over here, and then you're going to be down -2, just right in that spot for C prime. And then for D prime, it's -4 and just a -1, so really close right there on that 4. For D prime, let's go ahead and connect our dots together, and the shape should look the same as that shape, just reflected over. And you can see every point should be the same distance away. A should be the same distance away as A prime, same with all the others. Alright, so let's take our little break for the joke of the day. What do you say to a lollipop when you throw it away? So long, sucker. So long, sucker. don't know if they call lollipops suckers anymore. Maybe they do. Alright, so back to page 100. You'll see a little postulate right there that says reflection postulate. We had the same kind of one in the translations. This just says that a reflection is a rigid motion. The translation was also a rigid motion, and all that just means a rigid motion means that it preserves length and angle measure. You can just write that there, just underline rigid motion to remind yourself it preserves length and angle measure. So it's not going to change the size of the shape or shape of the figure at all. It's not going to change the angles in the triangle if it's a triangle and all that kind of thing. So here's the idea here, a reflection like this of this triangle. Here's the original, the pre-image. Here's the image with the primes. As it reflects over this line M, all of the lengths of everything here will stay exactly the same. So DF is the same over here as D prime F prime. All the angle measures inside of here are going to stay exactly the same. So the angle D is going to be the same as the angle D prime. It doesn't change it at all. Because if you change any of those, then it's no longer a rigid motion. So that's why it's a rigid motion always preserves the length and angle measure. Glide reflection down below here on page 99 is a vocabulary word. If you want to write this down on page 99 in the vocabulary. So basically what you want to say there is a glide reflection is a transformation involving a translation followed by a reflection. That's what a glide reflection means. It means you're going to first translate it, move it, shift it up, down, left, or right somehow, and then you're going to reflect it. So it's going to glide like a translation does, and then reflect. So that's what you do. So it says step 1, first translate, P to P prime. So that's what they're doing there. You're translating these up there, and then reflect over line K. And then they're going to reflect it over. So they're going to start with the blue one, move it to the red one, and then reflect it over. So you have the original here, which is just P and Q. Then you have your image here, which is P prime, Q prime, and then another image of P double prime, Q double prime, reflected over. So that's a glide reflection. Okay, so back to 101 for 7 and 8. We're going to do a couple glide reflections here on these. It says translate and then reflect. So it gives us a translation just like we learned in 4.1. Where it shows us, what to do to our points here. We're going to move the X, we're going to move the Y, and then we're going to reflect it after we do that in a particular line. They give us the lines here on these ones. So first of all, we need to plot our points, J, K, and L, on our coordinate plane. And you can notice on the coordinate plane, it is every box being worth 2. So you got to keep that in mind. So as we start with just J, 3, 1. So 3 to the right, and then 1 up is going to be our J point right there. Go ahead and plot that. K is 4, 2. So come over to 4 and go up to 2. And that's where going to be our K point there, and then 1, 3 for L. So just 1 and then up 3 for the L. And go ahead and connect your dots because it says it's a triangle. We're connecting the dots when it shows you the little triangle symbol here. So connect the dots to make the triangle. And now we're going to do our translation. So we're going to take each one of these X coordinates. We're going to subtract 6 from them, and each one of the Y coordinates we're going to subtract a 1 from that. So we're going to do this to it. We're going to do our translation now. So for these here, we're going to see 3. So it'll be a 3 minus 6 for J. So for J prime, we should call it J prime here. It's going to be 3 minus 6. That's going to be negative 3. And then 1 minus 1 is going to be 0. So negative 3, 0 for J prime. And I'm just doing that in my head. I'm putting that in my head. If you want to write that out, you can. Letter K, so for K prime, we're going to be putting in 4 and 2 in here. So 4 minus 6, that's going to be negative 2. And 2 minus 1 is going to be positive 1. So negative 2, comma 1 for K prime. And then for L prime, we're going to see 1 and 3. So 1 minus 6 is negative 5. And 3 minus 1 is 2. So negative 5, 2 for L prime. So now we do this, we plot these points. So we're going to plot these points here to make another triangle. So for the J prime, it's going to be at negative 3, 0. And I didn't put the J prime on here. I should have. You should do that on your paper. I forgot to do it on mine. You should put a little J prime, label these points. Negative 2, 1, it's going to be right here. It's going to be K prime here. And then negative 5, 2, it's going to be a little further over, negative 5 and up 2. That will be L prime. Should be labeling those points. I should have done that. I'm going to connect the dots to make another triangle. So it just shifted left 6 and it shifted down 1. That's what this happened. So that was just a translation. It's rigid motion still. Now it says to reflect in the line y equals negative x. Go ahead and draw that line. That's the negative x1 where you go up 1 and up 1 and left 1. You can use the boxes. That's fine. Up 2, left 2 is the same thing. So we're going to do that. Draw that line on here. We got to reflect this now over this line. And so we're going to take all of these points here. We're going to use these points, and we got to look back at our core concept and see, okay, what do we got to do to these ordered pairs? We're going to have to, since it's a negative, we are going to switch them, and we're also going to make them their opposites. So for the J double prime, we're going to switch these. 0 is going to be first. The negative 3 is going to turn to positive 3. So it's going to be, for this one, it's going to be the opposite of y, opposite of x. And so it's going to be 0, positive 3. And then for the K double prime, it's going to be 1 being first, but it's going to be negative 1, 2 second, and it's going to be positive 2. So it's going to be negative 1, positive 2. And then this one, the 2 is going to go first, but it's negative 2, and then it'll be positive 5 second. So negative 2, positive 5, and now we plot these points. So 0, 3, let's go ahead and plot 0, 3. So 0, 3 is going to be right up here. And then negative 1, and then 2. That's going to be right there, really close to that line of reflection. And then negative 2, 5. So left 2, and then up 5 is going to be up here. Let's go ahead and draw that little triangle up there. And I label all these points as the J, K, and L double primes. And so you can see how this is a reflection over this line. It's back on this side where the original was, but so now it's kind of a little bit of a different shape. Or not shape, I should say, a little bit of a different direction as it flipped over. Okay, for number 8, we're doing our translation here. X is going to stay the same, and then Y is going to be, basically going left, or I should say down 4. Sorry, this doesn't go left or right at all. It just is only going to go down 4 units. So let's go ahead and do the same thing, plot these points, start with our original, which is the same spot as that, because these are going by 2s. So let's just put them back on our coordinate plane, J, and then K at the 4, 2, and then L at 1, 3 again. So we put these back at the same spots as we had them here, so it's going to be pretty much the same as the beginning as this one, number 7. But now when we do this, we're going to just move it down 4 units for all of these. And that might be not hard to do. You don't have to do what I just did, but it's good to do that because you want to do that for these other points perhaps. So, it really can, this one you could probably do without doing all of this. This one you really did kind of need to do it to keep it straight for especially the reflection in the y equals negative x. I'm going to do it though for this one, at least for the translations. So we'll do keep the x the same, but you're going to subtract 4 from the y. So 3 is going to stay the same. 1 minus 4 is negative 3. So 3 negative 3 for J prime. For K prime, 4 is going to stay the same, but it's going to be 2 minus 4. It's negative 2. So 4 negative 2 for K prime. 1 will stay the same. 3 goes in here, so it's going to be 3 minus 4. That's negative 1. So 1, negative 1. Now we just plot these points. So 3, negative 3. That's going to be right 3, down 3. And I did label these ones. And then 4, so it's right 4, and then down 2 for K prime. Right 1, down 1 for the L prime. And let's go ahead and connect the dots. Make our triangle down there. So you can see how it just shifted down or moved down 4 units for the translation. And now we're going to reflect it over the line of x equals 1. So if it's x equals 1, we got to go to 1 on the x, and it's going to be a vertical line going through that. X equals 1. It has to be parallel to y because there is no y in this one. It can't touch y. That's why it has to be a vertical line. So you can go ahead and draw that line going through there. You can see how the point here of the L prime is actually on the line of reflection. So when we reflect this over this line, let's go and just map them. Let's start with the J here. So J looks like 3 to the right, so 3 to the left of this line, and it's going to have to stay on this very horizontal line right here, because it has to be perpendicular to the line of reflection. So it's just right over here, 3 to the left for J double prime. For K, that's going to be, looks like it's 1, 2, 3. So this one was 2 to the left, or 2 to the right, so 2 to the left. This one's 3 to the left, so 3 to the right for K prime, 3 to the left for K double prime. So we're going to be 3 over here for K double prime. And for this one, L prime, it's on the axis of symmetry, we would call it, or it's on the line of reflection. So that means that it is it's going to stay the same. That L prime is going to be the same thing as L double prime. They will equal each other. So we can label it also L double prime and then just connect our dots from there. And so these two are actually touching each other, just like if you were to, touch a mirror with your finger. It looks like the fingers are touching each other. Okay, so back to page 99 on the vocabulary. There's 2 more vocabulary that you want to write down, and that is a line of symmetry or line symmetry. And I was just saying that just a second ago, that the line of symmetry is kind of like the line of reflection. It is that, so it's what it says here. But basically, first of all, line symmetry. A figure in the plane has line symmetry when the figure can be mapped onto itself. That is line symmetry. So you want to write that down for line symmetry. And then for line of symmetry, so line symmetry would be when the figure can be mapped onto itself by a line of reflection. And then the line of symmetry is that line of reflection. So I have an example down here for A, B, and C. These are, different shapes. And it just basically asks how many lines of symmetry does each hexagon have. And first, you want to see, does it even have line symmetry? All of these have line symmetry. In fact, this butterfly right here has line symmetry because you can draw a line, this line M, right through the middle, and you can map this side onto itself. Basically, you could fold the butterfly over and it would map onto itself. Same thing we can do to these figures down here. So this hexagon here, they're all hexagons, 6-sided figures, has line symmetry and it has 2 lines of symmetry, one going this way where you could fold it this way onto itself, and one going vertically where you can fold it this way onto itself. Letter B has several more lines of symmetry. So this one not only has lines of symmetry like this one did, has those same ones going vertically, horizontally, but also there's diagonal lines of symmetry. You can do this way right here, going through these vertices, and that would fold it over and map it onto itself. Any vertice that it goes through here, because it's a regular hexagon on this one's not a regular hexagon, so that's why it wouldn't work here. If you were to draw it through here and then try to fold it, you're going to see it's not going to map onto itself. For C, the only line of symmetry this one has is right through the middle as a horizontal line for that one, because that's how you can map it. You could fold it this way and map it onto itself. You can't do that with any vertical lines. This one only has 1 line of symmetry. This one had 2. This one had, I think, 6 of them, I believe. So it has obviously 1, 2 this way, and then 3, 4, 5. I think is it 5 or 6? So we start with 1, 2, 3, 4, 5, 6. Yeah, 6 lines of symmetry. That's what I thought. Okay, so we're almost done here on page 101. Wants us to identify the line symmetry of the word. So we have 4 different words here from 9 to 12, and it wants us to identify where that line symmetry would be. Does it have line symmetry, first of all? Does the word have line symmetry, and if it does, where is that line of symmetry? So on the word moon, does it have line symmetry? Is there any way that you could draw a line through this word, usually like probably either horizontally or vertically, where it would map, if you folded it, it would map onto itself? And it doesn't look like it. If you draw it this way, that's not going to work. If you drew it this way through the middle, it's not going to work there either. So for 9, it has none. It has no line symmetry. You could say it has none on that one. For 10, can we draw a line of symmetry going along horizontally like this? No, that doesn't map that. It's not going to, can't fold it this way. How about going right through the O, right through the middle? Would that map it? Yes, that would fold it over. So we could draw this line. This one does have line symmetry, and it's going right through that O right there. Let's see, 11. If we drew this one vertically, obviously the K is not going to map onto the D, so we'd have to try this way horizontally, and I fold it down, and it does look like that would be a line symmetry this way. It looks the same above it as it does below it. So this one has line symmetry. The word dock, again, it's not going to work this way for a vertical line. Those are not going to map onto the other letters, but maybe going horizontally again, like we done in 11, works, and it looks like it will. This one does have also line symmetry through this way, so it maps it onto itself. And for 13, here's our last one. It says, you are placing a power strip along wall W that connects two computers. Where should you place the power strip to minimize the length of the connecting cables? Okay, so what you want to do here is we want to first do a couple things. We want to, we could look at this. I'll just open this up here so you can see it. It says, we're going to reflect A's computer. We're going to reflect it over line W. We're going to bring it over here. Just bring a reflection over there, and we'll label it A prime. So we can do that first. There we go. So we just reflected it over here, labeled it A prime. Then we're going to draw a line from B to A prime. So basically draw a line, a segment, a line here from B to A prime. And it goes through W, it goes through this line W. And so what we want to do is we want to label that intersection, label the intersection of this line with W. We want to put a point right there, and they say they can label it C. All right, we can label it C as well, I suppose. So we can say, okay, that's point C right there. And that is where we would want to, place our power strip. We want to place the power strip right there at that point because that's going to minimize it. As you can see what it says here for the rest of this. It says because BA prime is the shortest distance between B and AC equals A prime C. Okay, so that's what this is. A prime C, AC, right here. These are going to be exactly the same as well. That's why you want to place it right there. So these are going to be the same here, and these are going to be the same as well there. So that's why it's the shortest place between there to minimize the length of the connecting cables. All right, so that completes our lesson here on 4.2. And that was the reflections. So we did translations, we just did reflections now. The next one we'll be doing will be the rotations. And I'll see you on that lesson.